Welcome to Hugh TV 1. Today we're counting down the distances in space, not just between planets, but out where comets roam and where the sun's influence fades into the void. If you've ever looked up at the stars and wondered just how far away that edge is, you're in the right place. Let's travel outward from Earth, past the planets, beyond the Kuiper Belt, into the Oort cloud, all the way to where our solar system blends into interstellar space. First, astronomical unit AU. That's the distance from Earth to the Sun, about 93 million miles, 150 million kilometers. It's our basic yardstick for measuring the solar system. Light year, how far light travels in 1 year, about 5.88 trillion miles, 9.46 trillion kilometers. Useful when talking about huge distances. We'll use both units to help you visualize. Mercury, Venus, Earth, Mars, all packed relatively close in by cosmic standards. Then the gas giants: Jupiter, approximately 5 AU, Saturn, approximately 5 AU, Uranus and Neptune, approximately 19 and 30 AU respectively, from the Sun. Beyond Neptune lies the Kuiper Belt, a ring or belt of icy, rocky bodies. It extends from roughly 30 AU to about 50 AU from the Sun. This is where Pluto, Haumea, Makemake, Quoar, and many smaller icy objects orbit. The Sun doesn't just pull things in with gravity, it also emits a solar wind, a stream of charged particles. That forms a bubble around the solar system called the heliosphere. At about 70 to 100 AU, the solar wind slows down as it collides with interstellar medium. The termination shock, heliosheath, and eventually the heliopause, where the Sun's influence via solar wind effectively ends. Past there is interstellar space, though gravity from the Sun may still reach farther. The Kuiper Belt is big, but it's just the beginning. The Oort cloud is a theorized spherical shell of icy bodies that envelops everything: planets, Kuiper Belt, heliosphere. Inner edge of the Oort cloud is thought to begin between 2000 AU and 5000 AU from the Sun. Outer edge could stretch out to 100,000 AU, or more. That's up to about 1.5 light years away. Some estimates even range to approximately 2 light years depending on where you draw the boundary. To put that into human terms, even though Voyager 1 and Voyager 2 have been traveling for decades, they haven't yet entered the Oort cloud. It might take hundreds of years to reach the inner edge, and tens of thousands of years to get through the whole thing. Sedna, a dwarf planet, distant object, its perihelion, closest point to Sun, is approximately 76 AU, but its orbit swings it so far out that it's considered part of the inner Oort cloud. There could be other undiscovered objects even further out, possibly planets or massive bodies influencing the orbits of Oort, trans-Neptunian objects. Some astronomers hypothesize a Planet 9 type object. Where does the solar system end, really? That depends on which boundary you use. The orbit of the outermost planet, Neptune, approximately 50 AU. Easy to define, but rough. Heliopause, heliosphere boundaries, approximately 100 AU, where solar wind stops dominating. Oort cloud outer edge, approximately 100,000 AU or more. This is the outermost region where objects are still bound gravitationally to our Sun and are considered part of the solar system in many scientific definitions. Some researchers argue that once you're past the heliopause, you're in interstellar space, even if the Sun's gravity still reaches. Others say the solar system should include all bound objects, meaning the Oort cloud is the true edge. If you shrank the Sun down to a basketball, then Earth would be about 25 meters, 80 feet away. Neptune would be half a kilometer or more from that basketball. Kuiper Belt objects would lie beyond that, and the Oort cloud would be thousands of kilometers away, like from one city all the way across a country. Traveling at light speed, the fastest possible, reaching the inner Oort cloud might still take many years, but our fastest spacecraft, Voyager, takes centuries to reach those parts. It gives you a sense. Cosmic distances are huge, and even light takes time. Knowing the true size of the solar system helps us understand how solar wind, cosmic rays, and magnetic fields interact with interstellar space. It has implications for comet origins and how often comets might invade inner solar system space. Also, the outskirts of our solar system are still very mysterious. Many objects remain to be discovered. These might tell us how the solar system formed and whether there are more planets or bodies out there. If you found this deep dive into cosmic distance mind-blowing, hit that like button, subscribe to Hugh TV 1 for more journeys through space, time, and science. Leave a comment. What boundary fascinates you most? the Kuiper Belt, the Oort cloud, or something even beyond? And if you want, next time we can explore what happens when stars pass nearby, how they might shape or disrupt the Oort cloud, or even what lies between the Oort cloud and the next star over. Thanks for watching. Let's keep reaching for the stars.